type processor. So there are some, whenever you write any assembly language code to any specific type of processor, there are some instruction set or there are some instruction formats. We need to follow those formats to write a code, especially assembly language code, for those kind of processor. So for MIPS types of processor, there are 3 different types of formats to write the instruction, assembly language instruction. First of all, we before we go to the format of the instruction, we also have 2 different types of instruction. One is instructions, another one is pseudo instructions. Good news is we are going to use only the instruction. Now, at the moment, we are not going to study anything about pseudo instruction. What is pseudo instruction? For your information, it is written here. Pseudo instructions are provided by the assembler for convenience in programming, but we are not going to use that pseudo instruction. And how do you know that? There is a sign, this sign. I don't know the name of the sign, but this sign represents the pseudo instruction. Okay, for example, this one. This is a pseudo instructions example to move from source to destination. All right, so we are not going to discuss this. So we are just going to discuss the instructions, right? Instructions which we, the programmer, use as usual. Fine. So if you think about the instruction format, we have 3 different types. I type, that means immediate type. J type, that means jump type. And also R type, that means the register type. Most of the time, we use R type and I type. In this course, we have not used the jump operation. We have just know the jump. We can jump from one process to another process. We just know that, and we know some of the jump keywords. That's all. But we have never used it in this course. So don't worry about the second one. So we use the first one and we have used the second one, right? Just remember, for our knowledge, we have 3 different types of, or 3 different formats of instruction whenever you try to write assembly language code in MIPS processor. So the names are I type, which is immediate type, J type, that means jump type, and R type, that means register type. Fine. In this book, they have just described it very briefly. That's why I download one file from this website, because they have this website. I have downloaded it. So I will upload this file as well to the Google Classroom. I will. So this file actually, I mean, given a very nice explanation. So it's better we can see from here. So what is the first type? First type is I type. That means immediate type. That means whenever you write a code which has an immediate value, that means we have a value itself instead of a register, then that is the immediate type. All right. Let me tell you one thing. All these formats, you can see that it starts from 0 to 31. That means all the instructions are 32 bits. Can you guess why all of them are 32 bits?
Because MIPS processor only works with 32 bits.
Yes, because this processor is actually 32-bit processor. All the registers are 32 bits. So if your instruction is more than 32 bits, you cannot, implement it, or it cannot execute it in this processor. Fine. So we are using.
So it is technically limited to only 32 bits.
Yes, it is the maximum is the limit is 32 bits. Our format is 32 bits. Some of the parts we may use, we may not use, but these are filled up by the, for example, SA. Most of the time we use S0. All right, so altogether it will be 32 bits. Right, fine. So let's see one by one. The first one is the immediate type, or in short, I type. So we have opcode. Obviously, we know that it's an opcode. We have RS. RS means source register, and RT, that means they called it as a destination register, and this is a 16-bit immediate value. Right, so altogether we have this code, immediate type. Let us see an example. This is an example. Look at the example. We have example is like add I. Okay, what is add I? We have several types of add. Add, only add U, add I, and so many others. Add I means it is an immediate, we are using an immediate value. That's why we write this code, add I. Okay, we will see that we have two other types of add as well. But just for now, consider that add I means we are going to do addition, right? Where one of the value or one of the operands is an immediate type. So that's why we write add I. So this is the opcode, right? This is the opcode. We know that already that whenever we try to use any register in MIPS types of processor or RISC types of processor, we must use $sign before that register name. That's why it's a $sign. And then T2. And if you remember the table we have discussed in the previous chapter, that T0 to T7, we can use those registers as a temporary fuse. Look, T0 to T7, we can use it for temporary location or temporary save data. We have another type S0 to S7, 8 registers, that is save temporary. Then we can save it here. Fine, so we can use T and S. That's why we have used T and S. Fine. All right, so we have opcode, we have one register, source register, RS, we have destination register according to them, and then we have the value. So the question is, it says, well, in the format, it says that 16-bit immediate value. That means whatever value you have, it must be 16-bit. Look at our example. Our example is only 4. That means we need to convert it into 16-bit. Whatever the value you have to convert it into the 16-bit. Right? So now, if you think about the values, look how they have written 4 in 16 bits: 0, 0, 0, 0, 0, 1, 0, 0. Fine. So that's how we can write our code in assembly language for MIPS types of processor. One more thing we need to consider, we need to remember that MIPS types of processor or RISC types of processor, many times we use 3 operands or 3 variables to do any task. Let me show you. For example, addition, the simplest one. How many operands we have? 3. Register for destination, where we save the data, register for source 1 and register for source 2. That means we are going to add source 1 with source 2 and then store it into the destination register. So that is the way we do addition. If you think about the subtraction, also the same. Subtraction, destination, source 1, source 2, and we do source 1 minus source 2 like this. Source 1 minus source 2, and the result will be stored into the destination register. Yes, the result is stored in. So why I choose this one? Because this is an example that where we use 3 operands to do a task for subtraction and for addition as well. If you compare this addition into our 6 types of processor, if you remember our addition in 6 type, do you remember what is the 6 type addition? How we do the addition in Pentium processor?